Hello and welcome to the segment of ratios and proportions. My name is Keith B and I'll be your instructor for today. In this module, the objectives that we are going to cover will be understanding ratios, understanding percentages, and also understanding proportions. Start off with a ratio. A ratio is a comparison of two like or two similar numbers. In like a fraction, where a fraction is expressed as two numbers with a slash, a ratio is an expression of your numerator and your denominator, but your divisor in this case is a colon. Your numerator is expressed to the left and your denominator is expressed to the right of the colon. When we convert your ratio, it involves you have to making sure that all your quantities are the same unit of measure. What I mean by this, if that I'm going with a unit of milligrams, then that my other unit needs to be the same, milligram. If I'm going to micrograms, the other unit needs to be micrograms. If I'm going ounces, the other unit needs to be ounces. So if I have another unit that's not the same, then I may have to do a conversion to make sure that both of those units are similar. If we look at an example, 1/2 expressed as a fraction, and we take it and convert it to a ratio, it will be written as 1:2. A 1:2 ratio means that your second part is twice as much as your first part. So your denominator would be your second part, your numerator would be the first part. If I had 2/3 as a fraction, and I were to express that as a ratio, that's going to be 2:3. The ratio states that my denominator is 3 times as much as my numerator, which is 2. We'll first take a look and then we'll look at the conversion as how we come up with our correct answer. 1520 is 3/4. 7/28 is 1/4. 13/78 is 1/6. 12/60 is 1/5. 4/8 is 1/2. 6/9 is 2/3. 12/15 would be 4/5. And 132/144 would be 11/12. Now with each one of these examples, when you are converting to ratios, we always want to keep in mind that we want our least common denominator. And that's the lowest point where our numerator goes into our denominator. And the reason why we do this is sometimes we are converting, we don't want larger numbers, because when you're dealing with larger numbers, there is sometimes the possibility of coming up with an error. So if we look at our examples, if we look at 15/20, the common number in both would be 5. 5 times 3 is 15, and 5 times 4 equals 20. If we look at 7/28, 7 goes into both numbers. 7 goes into 7 once, and 7 goes into 28 4 times. If we look at 13/78, 13 is our multiple. 13 goes into 13 one time, and 13 goes into 78 6 times. If we look at 12/60, 12 is our common multiple. 12 goes into 12 once, and 12 goes into 60 5 times. If we look at 4/8, 4 is our common multiple. 4 goes into 4 once, and 4 goes into 8 twice. If we look at 6/9, 3 is our common multiple. 3 goes into 6 twice, and 3 goes into 9 3 times. If we look at 12/15, our common multiple is 3. 3 goes into 12 4 times, and 3 goes into 15 5 times. And if we would look at 132/144, we see a common multiple of 12. And 11 times 12 is 132, and 12 times 12 gives us 144. One of the things that we need to remember as we are converting, you have to remember what unit needs to be converted before solving the problem. So if I have a story problem that tells me that I need to go from milligrams to kilograms, I need to take a look at my problem and see which side of the equation or which unit needs to be converted. And then from there, I have to use the appropriate measurement conversion chart to help you convert if you have it available. One of the things that you discover as time goes on, that certain conversions will become secondhand to you. And the more that you do certain operations, you'll realize that you remember that a teaspoon will be 5 mLs or an ounce will be 30 mLs. So the more that you do your problems and the more that you do your exercises, the repetition will help all the different numbers and all your foundational base numbers go from your short term to your long term, and then it'll be second nature for you to remember. And this will help you as you do your conversions. And then also remember, always reduce to lowest terms, because as we talked about earlier, it's easier to multiply smaller numbers than it is larger numbers. And in healthcare, you always want to come up with the easiest way and the best possible solution to avoid a medication error. Let's look at an example of some conversions that you'll see. When you deal with length, 12 inches equals 1 foot. It takes 3 feet to equal 1 yard. 1 ounce will equal 30 milliliters or 30 grams. It will equal 30 milliliters if you're dealing with a liquid, and it'll equal 30 grams if you're dealing with a solid. So this is important as you're looking at certain conversions to make sure that you've got the correct unit. 1 kilogram equals 1,000 grams. 1 gram equals 1,000 milligrams. And a teaspoon equals 5 milliliters. Let's look at a common example. If I'm going to convert and look at the relationship of 3 inches to a foot, the first thing we need to do is convert the foot to inches. So our household measurement tells us that 1 foot is 12 inches. We looked at our problem to start off that we had inches and we had feet or a foot, so we couldn't solve this problem because our units don't match up. Now the other way that we could have gone, we could have taken the inches and converted that to a foot, and it would have been a fraction, but then we would have been multiplying a fraction times a whole number, and then sometimes that can lead to error. So when we're doing our conversions, we want to come up with the easiest way that we can identify our relationship. Now we have 3 inches to 12 inches as a ratio, and now we reduce to lowest terms. So if we look, 3 is our common number. So 3 goes into 3 once, and 3 goes into 12 4. Now if we were to work this out and look at the conversion, we start off with our ratio, 3 inches to 1 foot. We know that 1 foot is equal to 12 inches. So we also start off, we have to identify what is our relationship. So we say 3 is to 12, and as we stated earlier, our common number is 3. 3 goes into 3 once, and 3 goes into 12 4 times. And as we identified, our common number would be 3. A checks and balances, 1 times 3 is 3, and 4 times 3 equals 12. Let's look at another example. Look at the relationship of 6 feet to 3 yards. Now one of the things we have to remember is that when we're doing math problems, our foundation never changes. The rules never change. So as we apply the rules of what it is that we're trying to solve for, then we can go and plug in and solve the problem that we're looking for. So the first thing we look, we see a relationship between feet and yards. Our units don't match up, so we need to do a conversion. So we're going to convert our yards to feet. And 1 yard is equal to 3 feet. If we take 3 times 3, then that gives us 9 feet. Now we have a relationship of 6 feet to 9 feet. We reduce to our lowest terms, and 3 goes into each number. It'll be 2 feet to 3 feet. So if we work this problem out, we start off as a relationship of 6 feet equals 3 yards. Now we have to do a conversion. We already determined earlier that 1 foot equals 12 inches. And 1 yard equals 36 inches. So if we've got 6 feet is a relationship to 9 feet, and if we reduce this to our lowest terms, because we also determined that 1 yard is 3 feet. So we look at our relationship, reducing the lowest terms will be 2 feet to 3 feet as our ratio. Let's look at an example that deals with liquid measurement. 2 ounces as a relationship to 180 milliliters. Now, ounces and milliliters are different units, so we need to decide if we want to convert ounces to milliliters or convert milliliters to ounces. So what we're going to do, we're going to convert our ounces to milliliters. And our relationship is 1 ounce is 30 milliliters. Since it's 2 ounces times 30 mLs would give us 60. Then our relationship would be 60 mLs to 180. 60 is the common number, which is reduced to 1 to 3. So as we set this problem up, we always want to make sure that we set up our problem to look what we're solving for. So our relationship is 2 ounces to 180 mLs. We determine that 1 ounce is equal to 30 milliliters. And since we have 2 ounces, it equals 60 milliliters. So now that our units are the same, at 60 milliliters in relationship to 180 milliliters, 60 is our common number. 60 goes into 60 one time, and 60 goes into 180 3 times. So this would be a relationship of 1 to 3. Let's do another example. 5 teaspoons as a ratio to 175 mLs. First thing we want to do is we want to make sure that our units are the same. So we're going to convert our teaspoons to milliliters. 1 teaspoon is equal to 5 mLs. And since it's instructed us to give 5 teaspoons, 5 times 5 gives us 25. Now we've got a ratio of 25 to 175, then we reduce to lowest terms. We could use 5 as a number, but we see that 25 goes into both of these numbers. And 25 goes into 25 once, and 25 goes into 175 7 times. So if we were to set this problem up and work it out, it's 5 teaspoons as a ratio to 175 milliliters. We first have to identify that 1 teaspoon is equal to 5 mLs. And then it instructs us that we have 5 teaspoons. So then 5 teaspoons times 5 milliliters per teaspoon gives us 25 mLs. Now our ratio now is 25 milliliters to 175 milliliters. And now we reduce. 25 goes into 25 once, and 25 goes into 175 7 times. Let's look at an example that deals with weight. 4,500 milligrams in relationship to 3.6 kilograms. Now, we can go in 2 different directions. We can convert our milligrams to kilograms, or we can convert our kilograms to milligrams. If we look at our relationship at 4,500 milligrams, it takes 1,000 milligrams to equal 1 gram. And then from there, it takes 1,000 grams to equal 1 kilogram. We're moving across 2 units. So then that would give us 0.0045 kilograms. Or if we wanted to convert our kilograms to milligrams, we can take 3.6 kilograms and then show the relationship of how it takes 1,000 grams to equal a kilogram, and then 1,000 milligrams per gram, which would give us 3,600,000 milligrams. If you look at the examples that I've given you, the one on the top is a division because our units are on the bottom. The example on the bottom is a multiplication because our units are on the top. This is a rule of thumb, and if you go back to your metric system, if I'm going from a small unit to a larger unit, then I'm going to divide. If I'm going from a larger unit to a smaller unit, then I'm going to multiply. Just keep in mind and remember that it takes 100 pennies to equal $1, and it takes $1 is equal to 100 pennies. So if I'm going from a large unit to a small, from a dollar to cents, you can see how our decimal is moving to the right. And if I were going from pennies to dollars, I'm going from small to large, my decimal moves to the left. So then our relationship here is 4,500 milligrams to 3,600,000 milligrams, and then we can reduce by finding a common number, and 4,500 goes into both of these numbers. It would give us a ratio of 1 to 800. So let's work this out and see how we set this up. 4,500 milligrams in relationship to 3.6 kilograms. So we're going to convert our milligrams to kilograms. Now this is what's called a T-chart. I set up a T-chart because it allows us to put our units on the top and the bottom and provide a way to make sure that our units will cancel out. So if I go from 4,500 milligrams to grams, you see my milligrams on the top of the bottom, they would cancel, and that would give me 4.5 grams. Or what I can do, I can take my kilograms and go to my next unit, and it takes 1,000 grams to equal 1 kilogram. And then it takes 1,000 milligrams to equal 1 gram. So my kilograms would cancel, my grams would cancel, and this would give me 3,600,000 milligrams. Now, if we're converting a decimal to a ratio, the rule of thumb is that we will multiply the decimal by 100 or move the decimal point 2 places to the right. And then the number 100 will become your denominator. So remember that going from a decimal to a ratio, multiply by 100, and then 100 will become your denominator. So since we're setting up a ratio, we're still using the colon method, so then 100 would go to the right. So we have two examples. We're going to take 0.09 and convert it to a ratio, and we're going to take 0.675 and convert it to a ratio. If we take 0.09, our rule is to take our number and multiply it times 100. And since we're multiplying by 100, my decimal is going to go 2 places to the right. And this will be expressed as 9 over 100. Because a ratio is a part over a whole. So we look at 100 as our whole. If we look at the next example, we're taking 0.675. Our rule of thumb is we take our number and we multiply it times 100. So since there are 2 decimal places, or 2 zeros, we're going to move over 2 places, and that will become 67.5 over 100. And that would give us our answer. Let's look at a couple other examples. If we were to convert 0.47 to a ratio, our rule is our decimal moves 2 places to the right, and then we add 100 to become the denominator. So expressed as a fraction, it would be 47 over 100. As a ratio, it would be 47 to 100. If we converted 0.986 to a ratio, we move the decimal 2 places to the right and then add 100 to become our denominator, and 0.986 will become 98.6 to 100. And if you work these problems out, 0.47, you see our decimal is moving 2 places over and becomes 47 to 100. If we look at our next example of 0.986, our decimal moves 2 places over, 1, 2, and it becomes 98.6 to 100. And as a ratio, it'd be 98.6 to 100. Let's look at a couple other examples. If we take 0.02 to a ratio, it follows the same rule. We move the decimal 2 places to the right. We add 100 to become the denominator, and 0.02 will become 2 over 100. And if we're reducing, that will become 1 over 50. If we take 0.08 as a ratio, our decimal goes 2 places right. We add 100 to become the denominator, and 0.08 will become 8 over 100, which if we reduce it to lowest terms will become 1 over 12.5. So as we work these problems out, 0.02, we follow the rule. Our decimal moves 2 places to the right, 2 over 100. We have a common number in both of those because 2 will go into 2 once, and then 2 will go into 150 times. As we look at our second problem, which is 0.08, we follow our rules. We move our decimal 2 places to the right, express it as a ratio to 100, and then from here we can reduce because 8 will go into 8 once, and 8 will go into 112.5 times. Let's look at another example. Now here's an example where your numerator can end up larger than your denominator. The rule still stays the same because we're still going to move our decimal place to the right 2 places. We add 100 to become our denominator, and 1.25 will become 125 over 100. Now remember we talked about a ratio is the same as a fraction, which is a part over a whole. So if you think about it in terms of money, if it takes 100 pennies to equal $1, then that would be 1 whole. So if I look at 125, you can look at that as 125 pennies, which means that's 1 whole and 25 parts of 100. If we reduce this down to our lowest terms, we have a common number that goes into both of these numbers, which is 25. And 25 goes into 125 5 times, and 25 goes into 100 4 times. And if we express this as a ratio, it'll be 1.25 to 1. So let's go ahead and work this problem out. 1.25. Our rule is our decimal moves 2 places to the right, which gives us 125 over 100. As we reduce, that would give us 125 to 100 as a ratio, and we can break this down as a 5 to 4 as we determined earlier. And then from there we can still take it smaller as a 1.25 to 1 ratio. Another example, if we take 3 and express it as a ratio, our rule is the same. Our decimal is going to go 2 places to the right. 100 becomes the denominator, and 3 becomes 300 to 100, which is a ratio of 3 to 1. If you have a problem where you have a whole number that does not have a decimal, then at the end of the whole number is where your decimal would begin. So let's see how we will work this out. We have 3. Our decimal is at the end, so if we move it 2 places over, that would give us 300. The rule stays the same because our denominator will become 100, which is 300 over 100. And then as we reduce, this gives us a 3 to 1 ratio. Now, sometimes when we have situations where you have to convert a percentage to a ratio. A percentage is just like a fraction and just like a ratio because it is still expressed as a part over a whole. So example, 30% expressed at a ratio would be 30 as my part and 100 as my whole. 125% would be 125 as my part and 100 as my whole, which then can reduce. In example 3, 0.04%, which would be 0.04 over 100, which then becomes 4 to 10,000, and reducing to our lowest terms would be 1 to 2,500. Now the reason why I put the asterisks by there for you to pay attention to this is that sometimes the error, if we see 0.04 as a percentage, sometimes people may tend to write this as 4%, which it is not, because it's a little bit different when we have a percentage as opposed to a decimal. If we look at a couple other examples, 17% would be 17 over 100. 80% would be 80 over 100. We can reduce this down to 8 over 10, and then from there reduce it to 4 over 5, because 8 is our common number in both of these. And if I've had 240%, which is an example of your numerator being larger than your denominator, this is expressed as a part over a whole. 240 is my part or my portion, 100 would be my whole. I can reduce this down to 24 over 10, and then from here it can be reduced even smaller to 2.4 over 1, because 24 over 10 has a common multiple of 10. So let's look at some examples as we work this out. 17% follows the rule of expressing as a part over whole, which is 17 over 100. And as a ratio, it'll be 17 to 100. 80% is 80 over 100. As a ratio, it's 80 to 100. From here, we can reduce down because we have a common number, and we can take this down to 4 over 5 because a common number would be 20. 240% will be expressed as 240 over 100. As a ratio, it'll be 240 to 100. And then from here, I have a common number in both of these. I can reduce it by 10 over 100. And as I look here, 24 to 10 gives me a common multiple of 10, which would give me 2.4 to 1 ratio. Some more examples of converting percentages to ratios. 55% will be expressed as 55 to 100, which reduces to 11 over 20. 0.12% would be 0.12 over 100, which becomes 12 over 10,000, and 0.0013% becomes 0.0013 over 100, which becomes 13 over 1 million. If we look at 55%, we says 55% is a part over whole, which is 55 over 100. As a ratio is 55 to 100. We have a common number in each one, which is 5. 5 goes into 5511, and 5 goes into 120. If we have 0.12%, we express that as a part over 100. Now, when we move our decimal, whatever we do on the top, we have to do on the bottom. So if we move 2 places over, that will then become 12 over 10,000. If I have 0.0013%, if we express that as 0.0013 over 100, and however many decimal places I move on the top, I have to move the same amount of decimal places on the bottom. So on the top, since I'm moving 4 decimal places, on the bottom I'm moving 4 decimal places, which would give me 13 over 1 million.